So we are on currently still section 5.1.2, which is using a graph to find an inverse. So if you remember in the last lesson what we did, we started off with looking at a function and then being able to graph its inverse just from the use of the graph. We also talked about how functions, their inverse is reflected across the line y equals x. And lastly, we ended with learning how to graph a function and its inverse on a graphing calculator. And then the last problem that you guys did was finding the inverse of y equals x over 2 squared, or y equals 1/2 x squared. So let's go ahead and do that because we will need that for what we are doing today. So what we're trying to do is solve for x. So first we would square root y, which would give us plus or minus root y equals x over 2. And then technically from there, we're almost done. We would just multiply by 2. So we'd get plus or minus 2 root y equals x, and then we switch it. So our inverse would be y equals plus or minus 2 root x. Okay, so that is our inverse. So let's go ahead and look at question 21. So it says, consider your equation for the inverse, which is what we just found, y equals plus or minus 2 root x. Is the inverse a function? So we can graph this pretty quickly, but just kind of thinking about it, if we have a parabola and we reflect this parabola across the line y equals x, it's going to be a sideways parabola, right? With the plus or minus, we're going to have both the positive square root and the negative square root. Which means that this would not be a function. It would not pass the vertical line test. And also, it's going to have two different outputs for one input. So we will go ahead and answer this. So the inverse is not a function. So for a given input value, there is more than one output. Okay, so if I were, for example, to input 1 in for x, I would have both 2 and negative 2. So that automatically makes it not a function. So looking at part B, it says, use color to trace over the portion of your graph y equals x over 2 squared for which x is greater than or equal to 0. Then use another color to trace the inverse of only this part of the inverse of this part of the function. Okay, so let's go ahead and graph the inverse if we haven't already. So we already know to graph the inverse, we can simply graph the equation itself, or we can just kind of reverse the points. So since we have a point at 2, 1, we'll have a point at 1, 2. We'll have a point, we had a point at negative 2, 1. So we'll have 1, negative 2, and then we will have 4, 4, and then 4, negative 4. So this is what our inverse looks like, and I'm not going to say inverse function because it's not a function. So it's saying to trace the part where x is greater than or equal to 0. So that would be this piece right here. So if we were to just graph the inverse of that piece, they want us to trace that, and it would be this piece right here, okay? So that would be for part B. So we traced the x is greater than or equal to 0 for the function, and then we graphed that exact piece for the inverse. So it says to find an equation for the inverse of the restricted graph of y equals x over 2 squared, and how is this equation different from the original? So basically they're saying, let's just find the inverse of that piece. And so in order to do that, we would have to restrict the domain. So our new equation for the inverse would just be positive 2 root x. So the equation only includes the positive square root. Now, we could absolutely, if we wanted to make it a function, we could have done the other piece, right? We could have done the left side of the parabola and the bottom part of that square root function or sideways parabola. Okay, so looking at question 22, it's another parabola. So it's going to ask you, we already know if it's a parabola that the inverse will not be a function. So it's going to ask, how could we restrict the domain? So in other words, in this one, in order to make it a function, we had to restrict the domain and make x greater than or equal to 0. Okay, so they're going to ask about how could we restrict the domain for this particular parabola. And then for question 23, is there a way to look at any graph to determine if its inverse will be a function? So think about how do we test if something is a function, right? We use a vertical line test. So looking back at the inverse that we had graphed, we can easily tell it wasn't a function because it failed the vertical line test. So is there maybe another test that we can do on the original function that would determine whether its inverse will be a function? So that's what you need to figure out. And I will tell you there is. And then lastly, for question 24, it just says use the graphs to find inverses for the following functions. So label the graphs of each function and its inverse with the equation. So you don't necessarily have to graph it, or draw the graph. You can put it in your graphing calculator, and from there, you would then come up with the inverse. So it's, again, just practicing using the graph instead of using the equation. So you would want to put that in your graphing calculator or Desmos, and then from there, use those points to create the new points for the graph, which would then give you an equation that you need for the inverse. We are going to skip 25, and we will not be doing the math notes. The math notes for the notation for inverses, it's just saying basically if we have a function f of x, then the inverse would be denoted by f to the negative 1 of x. We kind of went over that on the first day of chapter 5, and I don't feel like we need to write it down. So that is everything for 5.1.2.